Hello everybody, myself Prof.S.V.Arlikar from AISSMS Institute of Information Technology. Today we are going to discuss determination of wavelength of light using diffraction grating. For this we need laser source and we have helium neon laser source in our laboratory. And when grating is mounted and laser light is allowed to incident on diffraction grating, then beautiful diffraction pattern is obtained. Referring to pattern and using formula A plus B sin theta equal to plus minus m lambda, where this is the equation describing principal maxima condition for diffraction grating. We can calculate the wavelength of light used by using formula lambda equal to A plus B sin theta upon m, where A plus B is grating element, sine of the angle theta, this theta you have to measure in the experiment, and m is the order number. For first order principal maxima m is 1, and for second order principal maxima m will be 2, and so on. The simple sketch of diffraction grating setup will be like this. This is helium neon laser beam. It is incident on grating like this, and we are able to observe the diffraction pattern on the screen. This is the screen, and this is the diffraction pattern. So this angle theta 1, this angle theta 2 we have to measure, where this theta 1 is for first order principal maxima and this theta 2 is for the second order principal maxima. You can observe the diffraction pattern obtained on the screen, actually how it appears in the laboratory, and measuring for right angle triangle, measuring this opposite side and adjacent side, and using tan ratio you can find out angle theta 1, which is substituted here, and with m equal to 1, and knowing substituting value of A plus B, the wavelength of light used can be calculated. How the diffraction pattern appears, that you will be observing now. You can see this is helium neon laser source of light. Then this is the diffraction grating mounted here on the stand, and this graph paper is nothing but screen in our experiment. Now you can see the diffraction pattern, and more clearly you can see when the light is switched off. When the tube light is switched off, you are able to observe the diffraction pattern like this. So at the center, the intense spot is there, which is central principal maxima. Nearby that, two spots are there which are referred as first order principal maxima. Again, after that there are two spots symmetrically placed on left hand and right hand side, which are second order principal maxima. So measure the separation between central principal maxima and first order principal maxima. Central principal maxima and second order principal maxima on RHS, similarly on LHS. Record these readings accurately and then measure what is the separation between the screen and the diffraction grating. Knowing these distances using trigonometry, we can find out what is the angle theta, which is separation for first order. Similarly, the angle theta, which is the separation for the second order principal maxima, and using the formula a plus b sin theta equal to m lambda, from which we have obtained lambda equal to a plus b sin theta upon m. Substituting values of a plus b, theta we have calculated by performing the experiment, and substituting the value of m as 1 for first order, wavelength of light used by first order and wavelength of light used by second order can be calculated. This is how, using plane diffraction grating, we can determine the wavelength of the light used. So this is what is the diagram for setup and the actual diffraction pattern in the dark room. You are able to observe like this. Thank you.